When we first arrived here and we realised that there was no natural gas in the village, the previous owners had oil, but we didn't want to get involved with oil because there were several problems about delivery and so on, the size of the tank, and the tank had to be within a certain distance from the boundaries, and there were enormous complications. And then the next sort of possibility was biomass, but then we soon realised that to make the cost reasonable, you had to have a huge amount of space for storage. And we'd heard about the ground source heat pumps, where you dig up vast amounts of garden and put the pipes about a metre under the ground. But that would have been very expensive to do and very disruptive for our small space that we had in front of the house. And then we were advised that why not the air source heat pump? Probably put in at the same time solar panels. We were then having an extension put onto the house. So it all was, it wasn't disruptive. We first met this particular contractor because he'd been doing some work for our son who lives just down the road. We just sort of instinctively liked him, and that's how it worked. Well, the solar thermal were installed basically for the domestic hot water system, and the air source for the central heating. Obviously, to have the two meant that in the summer you weren't using any electricity for your hot water. We were advised to put in an extra panel because in the winter, even with a small amount of sun, you got a sort of preheat for the central heating system. Insulation is vital to this whole system. When you have a new building, because of the building regulations, and you've got to have a well insulated house, and that of course is a very, very important aspect to this whole process of heating, because of the underfloor heating. The actual temperature is quite low, so it's a sort of continuous, in a sense, a sort of background heat. And if you make up great lists of pros and cons and have this and do we have that, do we have this, you spend all your time wondering and nothing ever happens. So we just went and did it. So the overall cost was about 14,000. The main job was installing the hot water tank and all the connections with the underfloor zones. There are about 9 different zones. The main tank is basically divided into 3 sections. It's for the EcoDan and the solar panels, but it's worked out very cleverly that you can isolate, if you want, the hot water for the domestic to the underfloor heating, but they work in conjunction with each other. There we have the expansion tanks for the underfloor heating, and here is the control panel, and it gives you the temperature of the collector, that's the on the roof, and it gives you the temperature of the bottom tank and the temperature of the top tank, which is the bit that's being heated at the moment by the solar panel. And the actual complication of fitting this very, very big tank and all the valves and the thermostatic controls and so on, that did take about a week, 2 weeks. The underfloor heating, in fact, is a lot of it is in the new build. So there was no problem about that. I mean, it was well insulated, and the old part, the existing part of the house, has a large radiator. It doesn't have underfloor heating. The disadvantage, in a sense, with this type of heat if you are going to have radiators, they've got to be very, very big, because it's, as I say, it's a sort of background heat. And of course, if you have big radiators, you've got the problem of where do you put furniture and so on. The builder who we were working with at the time suggested a very, very clever way of putting underfloor heating upstairs. And of course, underfloor heating, it's more efficient. He very cleverly managed to insert the pipes in cement so that they're sitting in like concrete blocks, which is sort of like storage heaters, really. We also have a wood burner, which is a very important part of the whole sort of system. Well, we're very, very pleased. I mean, we've had it for a year. We had a very, very cold winter last year. We had three weeks of extremely, extremely cold weather, and it survived. Undoubtedly, the Airsource heat pump, when it's very, very cold outside, is using more electricity because it has to compress what energy there is in the air. The ground source is always constantly at about 12 degrees or something. We were using about between 35 and 40 units for 24 hours. Yes, we live in a 3-bedroom house. We're constantly here because we're both working at home, and we've worked out that the cost is about £600 a year. And I would still be pleased if it was 700, and I cannot see it going more than £700 a year. So, we're very, very pleased with that, because it's a cost that seems to be very, very reasonable in a house of our size. I would expect about 1,200 probably, if one was using other, gas or oil. Because it's working on electricity, it seems the logical thing to do next is to put in the photovoltaic panels. I would certainly recommend it to somebody else, but I think it does, one's lifestyles, everybody's lifestyles are very, very different.
Out of the hill, we've got...
People have been coming to us, to look at them. And the one thing that the first question they say, what about the noise? How much does it make a lot of noise? Because it sort of hums when it's fanning full blast. It's a sort of loudish hum. But it's certainly not intrusive, not where we are, but then we have no neighbours. And I always say that you've got to have a well-insulated house if you have this particular system of heat. And I would also recommend that they have it working in conjunction with the solar panels. Because if you had to rely on that for your hot water as well, then your electricity bills might be unnecessarily big, I suppose. Yes, I'm very satisfied with the system that we've got, and I don't think that if I was asked, if I had to do it again, would I do it differently? I think, no, I don't think I would do it differently.